hello, it's Cliff here from Down Under. I'm just doing a bit of maintenance on this old 2007 Tormach 1100, and I thought it would be a good opportunity to do an inspection and an overhaul and a bit of maintenance, and why not do a review on this 16-year-old machine at the same time. Okay, so soon I'll pull it apart and check its cleanliness in the key areas, you know, the ball screw, the slideways and so on, and then lubricate it and adjust it. But before I do that, let's just check it in its current condition, just how accurate it still is. So I've put this angle plate on the table, which I know is very accurately square in all directions. I've tested it with a squareness comparator. I did a video on how to easily build and use a squareness comparator. If you look on my playlists under metrology, you'll see a couple of videos on the squareness comparator. So I know this angle plate is within 1/10 of a thou over the 4-inch size of it of square. So it's very accurate. I can now clamp it lightly on the table, dial in the front face and check the X and Y squareness and the Z squareness in both directions, and also test the backlash on the 3 axes. So I'll set the camera up now and go through that with you. Let's have a look at how accurate the 16-year-old machine still is. Of course, this is a Series 1 machine, but I installed the upgrade kit to turn it into a Series 3 a few years ago, you know, with new steppers and drivers and a main control board. And if you are thinking of doing that, I've produced a video on that subject of how to upgrade and install that kit. If you look on my YouTube channel, you'll find that there, I'm sure. So I've removed the backlash compensation that I had. I only had a little bit on the y-axis. If you type in admin, you can see here get axis backlash, enter, and you can see up here I've currently got no backlash compensation set, but I only had a 0.011 on the y-axis. Anyway, that's gone now, so let's just measure the machine as it is. Alright, so first of all, I've dialed in the front face. I'm getting a little bit of needle deflection, but that's pretty good. Okay, so let's test the Z squareness, the perpendicularness of the column, of the head going up and down. Well, that's really good. There's a little bit of needle flex on the dial indicator, but it is square within 0.5 there. Let's test the Y backlash. So I'm going to step in with the smallest settings until I strike 0. I'm going to set 0 on the YDRO and then start stepping in the other direction until I see the needle move. 3, 4, 5, 6, just started to move there, and that is showing 0.022 backlash. So probably the last 2 microns was that movement. So we have 0.02 of a millimeter backlash on the Y axis. That's less than a thou. That's very good even for a new Tormach. Alright, let's do some tests on the other side. Let's traverse the Y slideway. So that's looks like 1/100th of a millimeter. One-hundredth of a millimeter out of square between the X and Y slideways over 100 millimeters. That's less than 1/2 thou over 4 inches. That's pretty good. I'm pretty happy with that. Let's try the Z vertical and this the right angle going vertically. Bit of needle flex. It's about 1/100th out. That's pretty good. So the Z is almost perfect, front to back, and sideways it's 1/100th of a millimeter out, less than half a thou, and the X to Y sideways are out less than half a thou over 4 inches, 1/100th of a millimeter over 100 millimeters. Okay, that's really good. I'm really pleased. After 16 years, that's about what I remember it was when I tested it when it was new. Alright, well, let's test the backlash. We will, on small steps, come into 0. We'll set the XDRO on 0. We'll change direction and go the other way and see how many steps before the needle starts to move. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think it's moving now, 9. So that's 2/100th of a millimeter. So just check that again. Coming into 0, 0 the DRO, go the other way. So it was about 8 steps. Yeah, just under 2/100ths of a millimeter backlash in the X. That's very similar to the Y, wasn't it? So that's less than a thou. So they both have less than a thou backlash with no backlash compensation applied. If you're interested in backlash compensation, that is not a cure-all. It's a two-edged sword. There's real problems with using it. You've got to be careful not to overuse backlash compensation. It's very limited on the Tormachs. I've done a video on that subject. If you look in my playlists under Tormach specific and then find the video backlash compensation, you can't use too much of it or you'll make the machine less accurate than it was before you applied it. Well, that's great news. This machine is still very accurate, and I'm thinking, do I need to pull it apart and check it further? Well, yeah, I think I should, because maintenance is also about cleanliness, and it's really important that the ball screws and slideways are as clean as you can possibly make them. Little bits of abrasive particles that may be suspended in the coolant that may drip through onto the ball screws will rapidly wear out your ball screws and ball nuts and slideways, and so it's really worth spending a bit of time every few years, ideally every couple of years, and cleaning it all down, washing it out with kerosene, wiping it clean, making sure there's no abrasive particles in any of those areas, and putting fresh lubricant on it and adjusting up the gibs and so on, and that way the machine will last indefinitely. But if you just ignore these things and let the contaminants get onto the ball screws and slideways, it won't last very long at all. You'll rapidly wear them out, and if you allow them to run with the gibs loose and abrasive particles in there, things will go pear-shaped very fast. Have a look at that video if you can find the time. Tormach's maintenance and leveling. Alright, so now let's just test the vertical backlash. So we'll come down into contact there on the top surface of this precision angle plate. We can check there to show that the angle plate is sitting accurately on the table. We're also checking that the slideways are running flat in both directions, so they were pretty good, within 1/100th of a millimeter. I mean, obviously if you had a $200,000 vertical machining center, high precision machine, you'd be using a finer graduation dial indicator in microns or tenths of a thou, and you'd be in a whole different league. What we're talking about here is a budget CNC that often have errors of several thou, and this is a very good one. We've got errors mainly of less than half a thou, often only 1 or 2 tenths. Now let's test the vertical backlash or the loss motion. So we're going to step in here until we're on Z0, enter 0 on the DRO and change direction. 5, 6, 7, it's just moving now on 7. Yeah, 7 clicks, that's 0.02 of a millimeter. That's less than a thou. That's really good, because remember with the Z, you're not just testing the backlash in the ball screw, you're also testing the whole racking of the vertical slide, because you've got the weight of the head hanging out here, and you've got a certain amount of variable stictions and frictions with the ball screw, the vertical slide, the dovetails, the lubricant, the whatever is in there, abrasive particles. The head can rack and respond with delay. It'll droop down, then when it's pushed up it can stick and spring the other way, and when it's reversed it can stick and spring the other way, because you're measuring it a long way from the slide. That is pretty amazing. You know, even for a high-end vertical machining center, you're going to get quite a lot of lost motion at this position. So here we have 0.02 of a millimeter. I'm really pleased with that. Well, I should discuss the spindle, shouldn't I? It's an important part of a milling machine, and it's been great for the last 14 or so years, but I had problems with it when I first got the machine, and the spindle bearings got really noisy, and I had to replace the spindle bearings. And when I had it apart, I had a good look at the design and did a bit of research online, and started to realize that the design of the Tormach spindle bearings is a compromise, like most designs. It has angular contact bearings, pairs of them at each end of the spindle cartridge, and the preload is adjusted with a nut here. I've sort of got it diagrammatically laid out here just to give you an idea while I'm talking. Now this design has pros and cons. It's very easy and cheap to make, and it is very rigid, but there are problems with getting the correct preload. It's very easy to have the preload too high or too low, and preload's really important, because if it's just right, the spindle will last a long time and be rigid. But if the preload is too great, the spindle bearings will break down quickly, and if the preload is too little, that will also cause problems with accuracy and rigidity and bearing life. So the problem with this design with the bearings at opposite ends of the spindle cartridge is, as the machine heats up, the spindle bearing heats up, the cartridge heats up, and the coefficient of linear expansion of the steel parts means that the preload changes, and so you can have the right preload at one temperature, but then it becomes the wrong preload. So setting the preload into its optimum compromise position is very critical on these machines, and I was concerned about this. So when I put new bearings in, I developed a carefully calibrated spring that goes under the adjusting nut, and I worked out what the correct amount of preload should be for that spring. So now on this machine, the spring takes up the variation in the thermal expansion, so the preload doesn't vary. The preload stays the same whether the machine is cold or hot. Well, this would be a really good feature to have on other Tormachs with this design of spindle, but it's quite a bit of work to research, develop and install that type of preload spring. But since that was installed 14 years ago, I haven't had any trouble with the spindle bearings. Well, as mentioned, I've done a full video on Tormach maintenance already. You can find that in the playlist. So I'll just talk about a couple of details relative to the condition of this machine. So I've cleaned down the Y-axis, slideways and ball screw, and they were reasonably clean. in the important areas. Not perfect, but not too bad. And flushed them all out with kerosene and oiled them up and tried to adjust the Y gib a little bit closer, but I really couldn't. Even half a turn of the adjusting screws caused the slideway to pinch up and increase the backlash, and that's a sure sign that the gib's too tight. So I can't remember, I haven't looked at my notes when I last adjusted the gib on this machine, but it would be several years ago, and there's been no noticeable wear in that time. If a machine tool is well designed, well built and well maintained, there's no reason why it can't last indefinitely. For example, this old Brown & Sharp was built in the 1940s and it's still able to do high precision work. This machine could run for hundreds of years in theory if it was well maintained. But if one of those factors, original design, quality of build or maintenance, is substandard, then it's a whole different story. Well, I'm really pleased with the condition of this 16-year-old machine. I'd have to give it a 5-star rating, and that's for what it is. It is a budget, low-cost, home hobbyist, small shop CNC. It's not a vertical machining center, and for what it is very good. But that's specific to this machine that was built on that day. It doesn't mean that all Tormachs are of similar quality or accuracy. Okay, so what I'm going to do now is pull the covers off and get inside it and check the ball screws, see if there's any abrasive particles on it, wash them down, clean them down, re-lubricate them, check the gibs are adjusted, and probably apply a little bit of backlash compensation if that is appropriate. And I could make a video of that, but it would be very long-winded, and I've already done that. On this machine that I bought in 2014, there's already a video on cleaning, maintenance, and leveling and checking the condition of it. So if you're interested, rather than this video being another half an hour long, go and have a look at that video. So on this YouTube channel's playlists, if you look under machinery and maintenance, you'll see one Tormach maintenance and leveling, and I go into that subject of how to clean it down, lubricate it and adjust it. And I also cover making sure that your main base casting, that's this casting, is not twisted, because I think many of the Tormachs out there are not sitting in a way where the base casting is in its relaxed and accurate state as it was when it was built in the factory. It's very easy to have that very light base. It's just a hollowed out biscuit tin of a base, has very little rigidity. It's very easy to have that light base twisted, and therefore introducing errors into the machine that will cause errors in its squareness, in its backlash, and also cause it to wear much more rapidly because the slideways are not aligned. So while this review gives you a bit of an idea of the condition of this particular 2007 Tormach, obviously there's a lot of factors involved in any given machine. I mean, the original design, the quality of the design, the quality of the manufacture of that particular model, of that particular machine itself on that particular day, how well it's been maintained, how well it's been adjusted and lubricated, and how hard it's been used, all have a big impact on the condition of the machine. So you can't generalize and say all Tormachs don't wear much in 16 years. It's just relevant to this particular machine, but I hope there's some information in there that's been useful for you. Alright, thanks for watching guys, and stay tuned for the next exciting video. Cheers.